Welcome, everyone, and thank you for joining us for Tool Talk Episode 4 featuring Unredactor. I'm Joe Seckman, AVP of R&D at Bishop Fox, and your host for today. Before we get started, I'd like to run through a few housekeeping items. To submit questions, use the Q&A tool on the left of your dashboard. We will try to answer throughout the webcast, but we'll also have a dedicated Q&A session at the end. If you experience any problems during the webcast, please let us know by using the questions module or the help tool. A recorded version of this webcast will be made available promptly when we conclude. Let's meet today's speaker, Dan Petro, lead researcher here at Bishop Fox. Dan, please take a moment to introduce yourself.
Yeah, hey everybody, I'm Dan. Like I said, lead researcher here, a longtime pen tester as well. Without cutting too much into the meat of the talk, yeah, I was once also the head of tech QA at Bishop Fox, and so this is a piece of research that sort of came out of that. So I'll leave it there for now.
Excellent. There's some context there for you. Okay, moving on to our agenda. First, as Dan mentioned, we'll talk a little bit about how pixelation works, what's the genesis of this research, a little bit of the backstory about Unredactor, obviously deep diving into Unredactor, as well as Dan providing us a live demo of the tool. And as always, we'll save some time at the end for some Q&A and some questions that may come up. But before we get started, first things first, what I'd like to do is just kind of gauge a little bit about the familiarity with redaction and different techniques that are out there. How concerned are you about popular redaction techniques such as pixelation, blur, or swirling? And by concern, I mean, is this doing the job that I'm intending it to do? Very concerned, never used these types of techniques for redaction. Somewhat concerned, but used them anyway, or not concerned at all. Information isn't necessarily sensitive. I'm just going to put it out there and not worry about it. So while we leave this up, I urge the audience to go ahead and make a selection here just to get a good idea of where everybody sits. Dan, I'd like to kick it over to you just for a little bit of backstory about the genesis of Unredactor and how that tool came to be.
Yeah, absolutely. So like I was mentioning earlier, I was once the head of tech QA. So all of the technical documents that we produce at Bishop Fox go through a process of tech QA, basically peer review before they're actually submitted to clients. And we necessarily, as a pen testing firm, have really sensitive information inside of these technical documents that we produce as basically step-by-step instructions about how to hack into some of the biggest companies in the world, right? And so along the way, we might have a need to redact certain information. So the quintessential example of this is like the domain admin password. If we break into some company and we steal a domain admin password, we might not want to include the actual password verbatim in the report for fear that it might be still live, not changed yet, or for whatever reason, right? And so there's extreme examples like that, but actually much more common examples of redactions that come up in reports are things that are not necessarily sensitive, but personally identifiable. So usernames or email addresses. So something really common that happens is we might compromise a particular user's workstation just in the process of whatever attack chain that we're doing. It's not necessarily that user's fault. And so we don't want to throw any individual under the bus when it might as well have been anyone in the company that we had, hijacked the computer of. And so we'll take the username, the host name, email address, whatever identifiable information that is, and redact it in the report so that it doesn't appear, it doesn't look like that person's fault, right? So the question then becomes, how do you actually do this redaction? And people tend to get really fancy with things. They try to use a whole bunch of different redaction techniques, like blurring and swirling and pixelation is one of the more common ones you find. And so this was always a pet peeve of mine as I was the head of tech QA, that there wasn't really a good tool to undo this information, but it clearly leaks information, right? When you're looking at a blurred image of something, you're not seeing nothing. You're seeing some information. Information is coming through. And it always was apparent to me, anyway, that there ought to be a way to undo that redaction technique. If you pixelated some text, why can't you just get the original text back from that? But there just wasn't a good tool to do it. And so I after a while, I kind of set out to do exactly that. So Unredactor is more or less a way to follow up a couple years later after the fact on an old pet peeve that had always bothered me. People would try to make some pixelated text in a report, and I didn't have a good way to demonstrate why it was bad, but I just knew in my bones that it was. So I figured that it would be a good way to exploit that. So I think a good way to get started is to dive into like exactly how does pixelation work, and how does Unredactor work to undo that process. So I'm going to share my screen now.
Yeah. Hold on one second.
Yeah,
before we get into there, we've got a couple more responses trickling in here. I just wanted to see the poll results, and then we'll jump straight into your demo. I know you're itching to get to it. So awesome. This is fantastic. Now, if there was a right answer for a poll, it's kind of like itching towards the first, but at the same time, I think a lot of folks, at least folks that have been through the industry, have kind of fallen in the middle with the somewhat concerned but use them anyway aspects. Like, I think, Dan, one of the things that really resonated with me when you were first talking about this project and this idea is that there's a lot of academic research that's out there that says this is possible. But again, it's one of those things where it's like, is it possible or is it actually, feasible and demonstrable? Right. And I think that's where Unredactor really shines. It comes through. So the very concerned, never use them aspects, I think that crowd from a security perspective makes a whole lot of sense in the context of this talk. And I think seeing is believing is kind of the name of the game here. So, all right. Hey, Dan, sorry to interrupt you on that. I don't want to keep you from your demo at all, but by all means, I think, take the screen.
That kind of thing is common in security too, where like, maybe we academically understand that something might be possible, but like if there's not good tooling for it, how afraid should you be of it? And that kind of really rings true to pen testers too, where there's kind of like this mantra, especially at Bishop Fox, of like, if you can't exploit it, how do you know it's vulnerable? Like, how do you know that there isn't something in the way that would prevent you from doing it? So having a proof of concept, like having a tool that can actually do the thing, is really important towards demonstrating that it really is vulnerable, that this isn't just a theory that could be wrong. So that's also partly the motivation behind this. So, all right, let me start the screen share and hope that this doesn't break everything. Cool. So first here, I'm just going to describe like how pixelation works at a mechanical level in order to better understand what Unredactor is doing to kind of undo that process. So this is just GIMP here that you're seeing me type some text into, such secrets. So this is going to be an image of text here. I'm going to combine the layers so that they just merge down. Cool. So now we can do something very common in the reports. We're going to take some segment of this and we're going to redact this. So there's already some built-in tools for redactions. You can do all kinds of things here. There's different algorithms for blurring, Gaussian blur, median blur, different kinds of blurs, and pixelizing is one of these. So also, depending on who you ask and where you go, it's either called pixelizing or pixelating. We went with pixelate in our internal discussions, but you'll see it different ways. It's not important, but I wanted to point that out. So there's two big attributes here that you're going to want to see about how pixelation works. The basic process is that it's going to take a block of size n, whatever this happens to be here. We can make it bigger, we can make it smaller, and it's going to take all the pixels in that block and kind of smear them out. It literally just takes an average. So it takes the average value of all the pixels within this block and sets them equal to that average. So you can think of it as a smear. It kind of takes all the pixels in here and smears them out to everything within that block. And so there's two major settings to be concerned with here. There's the block size, which is this. So you can make it bigger and bigger, all the way down to 1. If you make block size equal to 1, then it literally does nothing, right? Because every pixel is just equal to itself, and you have the original text. And if you make it bigger, you wind up getting it like smaller and smaller, or rather the text is getting smaller in a sense. The blurring is getting bigger up to the point where it starts becoming fairly unrecognizable, where this is like pretty unrecognizable by itself, whereas this is pretty readable, even though it loses some fidelity, right? And somewhere along the middle is like something like this, where it's fairly unreadable, but the information is still there. And the second piece of information you want to know is this offset. So this is a little bit complicated. The idea behind this is that where you start in making these blocks matters in the final product of what they look like. So if I increase the X offset here, you can see how it kind of moves to the right in a sense every time I increase this, and it's a modulo whatever this block size is. And depending on what this block size is, the image can wind up looking quite different. So like this right here looks quite a bit different than this right here, even though they're the same text and the same block size. Just where you happen to set this is what like determines the block size. And now this is mostly random because it's basically, even if you set the offset to 0, 0, in practice it's going to wind up being set by where you set this bounding box. So when I do this right here, I'm kind of implicitly setting the offset by how far this box is from the middle, from like the edge of the S. So that's not a very reliable process. We can't count on this to be 0, 0. It's basically going to be random. So we're going to have to guess this, this offset. So what Unredactor does is it's going to just be a brute forcer for the text. So we're going to assume that we have received text in a form that's mostly like this. So we have some bits of text that are not redacted, and then we have some bit that is, which is pretty reasonable, since most of these like instances where you'd want to unredact some text comes in the context of a report where you're not just given the pixelation, like you're given a like normal text as well. So from this, you can get the font and the font size. So we can reliably reproduce this in something like a headless Chrome, and then move forward from there. So what Unredactor is going to do is it's going to be actually what I'll do is I'll run it here, and then I'll kind of talk over it as it's running. So it's going to take a minute. So this is an Electron app. It runs a little bit slower while I'm presenting, since my machine is going to be a bit taxed. So I'm going to let this run, and I'll kind of talk over it while it's going. So the very first thing it's going to do is it's going to try to discover what the X and Y offsets are. So that's what it's cycling through here. So it's going to go through all the letters, A through Z and space. For right now, we're just looking at lowercase letters, A through Z, and spaces. And you can change that if you like. This is just to make the process a little bit simpler. In practice, you can have it include literally whatever character set you want. And so each time it iterates through a letter, what it does is it produces a guess in headless Chrome, crops it down to the right size, and then compares it, does the pixelation process forward, and then takes that guess, which you see here in the bottom, and compares it to the redacted text and says like how well the match did it work. So you can see this right here, a W kind of sort of matches. It's not perfect. It's not great. Like this block isn't the same as this block here, and this has too much of a color to here maybe, but it's starting to get kind of close, and the guesses will start improving. And at this point, it's not actually trying to guess all the letters. It's just trying to find a good offset, and here it found one. So 2, 5, 2 for the X and Y, 5 for Y, winds up being a good offset to try. That means that the letter W wound up being a pretty good fit. And you can see that here, that the W is actually a really good fit for those first few pixels. Well, what it'll do is it'll accumulate a few more like guesses for it to try. And then once it's gone through all of the possible offsets, 0, 0 through 7, 7, then it'll actually start trying to guess letters for them, like going forward. And it'll do that in a depth-first search. So it'll try to find 0, the first letter, go with that, and keep going forward. There's a whole bunch of logistical problems with this along the way that I'll kind of get into a little bit later. But this first process is pretty straightforward. We just go through all the letters, A through Z, pixel space for all of the offsets, and just keep note of any of the good offsets, basically offsets within a certain range. Actually, now's not a bad time to mention the comparison process. So when we do the checking, like when we compare this redacted text against our best guess, it uses a fuzzy matching process. So it's not an exact like pixel for pixel thing. You can use an image distance algorithm to tell the difference, like basically this image minus this image, and you can get a distance, like literally like a geometry wise, and basically how close they were. And using that metric, we can partially guess images. And so that really helps out because we don't need to get the text exact. We don't need to have like this, like if this exact W is slightly different, that's actually okay, because the process doesn't need it to be exact. It's okay if it's like a little bit off. Now, if it winds up being really off, that becomes a problem. In practice, one of the big things is character spacing. If the character spacing between the W and the O is a little bit off, it'll cascade down by the end, where the first couple letters will be correct, but then by the time you get to the middle or the end, you're like a whole character off from where you should be. Cool, so we just hit 7.7, and now we're getting into the real guessing. So now we jumped to offset 2.5, and we're guessing actual letters. And you can see here that it will start to guess the letters one by one, quickly zeroing in on the correct guess. So again, then this actually is running quite a bit slower than it normally would if I weren't screen recording. And also, if my machine were just a little bit beefier, it'd probably run faster too. But this is about as good as I can manage to get it right now. So you really see the depth first search run once we get to the end as well. It'll kind of get to the end of the line and then back up, and then start guessing additional things.
Yeah, I was going to mention too, depending on what actual text is being redacted, the accuracy of the single individual characters may not matter so much, right. Given that, like, if it's something that you can infer what the meaning is, just based off looking at one letter being off versus something where every letter needs to be correct, like a password, or every character, I should say, needs to be correct, right, like a password. So
yeah, that's
either
really
way, you're revealing it.
Yeah, in certain scripts as well, because this is font independent, you can change the font to be whatever you want. Some fonts were like an O, or a better case is lowercase L and 1 might be very similar. And so telling the difference between those visually is going to be basically impossible. But maybe it's not important, right? Or like if you're reading if it's English text, you could probably tell from context that it's like probably an L, not a 1 or something like that. Whereas if it's a password, then you might need to do some finagling. But this will get you, 95% of the way there.
I think that actually fits into one of the questions that we just received. Shouldn't the font type be taken into account as well, or the distance algorithm is good enough? Yeah,
the font really does matter. It matters quite a bit. So in this case, it's just like hard-coded to be the font that I'm using. But yeah, you're going to need to change that. And that's kind of outside of the scope of Unredactor to determine what the font is. Yeah. I guess in theory, one could do that, like have some, I don't know, machine learning algorithm or whatever that like auto detects what the font is. But in practice, it's actually really tricky to like look at the font and figure out what that is. So also you need to get the font size and then a couple of other attributes around. It's not just font size. You need to have, so this is in Electron, so you have full control over like the HTML of it. So basically anything you can do with CSS, you can do to mess with the spacings here. So in particular, like I said, character spacing, the kerning, how much space there is between letters is really sensitive to, and word spacing, so how much spacing there is between words is really sensitive to. Other than that, like there's even some cross-compatibility issues. So this is, again, rendering things to headless Chrome, but I've noticed that there are some minor differences between like rendering engines and cross-platform. So like Chrome just will render things differently on Windows versus Linux. And it's small, and in practice, I haven't had it matter, but that is a thing that happens. And some rendering engines are just like wildly incorrect. They just like generate text that's like not how it looks like it should be. If you just look up references online, even of like, here's what, Arial as a font should look like. And then you look at how, I'm not sure what a good one is, like Notepad or like a certain PDF renderer that makes its own rendering engine, right? How it generates text might just be like wrong. And so your ability to reproduce that text in Chrome might be suspect. But again, as long as it's close enough, it's probably fine. Where like, W and O look quite different. And so that's probably good enough.
Yeah, Dan, and we've got a couple of questions that are basically extracting the same theme here. Is there a specific reason why you've chosen Electron instead of a simple browser application, and it doesn't appear to work on Apple Silicon in its current form?
Oh, yeah. So making Electron work cross-platform turned out to be a larger endeavor than I originally imagined it to. So one of the reasons I chose Electron as a platform to make this work in was twofold. One is that it's kind of made sense for it to kind of work natively in HTML and JavaScript, since this is going to be kind of rendering, and I knew I wanted a GUI. And also, I was just not very familiar with Electron and JavaScript. It's easily my worst programming language, and so I kind of wanted an excuse to make an Electron app from start to finish. That said, once I had done that and finished it, actually making it work cross-platform was like a huge task. Like the dependencies are just a nightmare. Like even just upgrading the version of Electron changes everything. Like basically, if you change anything, like everything stops working. And so there's no reason that this shouldn't work cross-platform and work on Macs or whatever. I'm sure that if we tried hard enough at it, we certainly could. But I don't have a Mac to test it against, and I have no idea what those errors are that people are getting. So it's just kind of beyond my capability to fix that. I'm sure that it's just something incredibly minor, but I guess that's the answer. It's not a great one, but that's the answer.
Yeah, and I think along those same lines, knowing what you know now, would it work better in a different language? And what would that language be?
Yeah, absolutely. I'll just switch back to my face for the moment so you can see me. The answer is absolutely. I think in retrospect, if I just wanted to like make the shortest path between like having like me right now and like a working program that runs really fast, I would do this in Golang, like easy. One of the main limiters in doing this in Electron is that it's single threaded. And if you're making like a brute forcer, like I really want to be able to have this running in multiple threads, and you just kind of can't do that. It's also CPU bound. So while Electron is really great at concurrency, when they're CPU bound, like that doesn't really help you. So I feel like if I were to make this with like this really good series of Go routines, like I could make this a lot better. It wouldn't be as fancy. It wouldn't have like this pretty GUI or whatever. At least I wouldn't be good at doing that in Go. But I feel like it could be an order of magnitude faster and more efficient, and probably less buggy too. But that is less of a jab at JavaScript and more of a statement about how I'm more proficient at Go than I am at JavaScript. So.
No, fair enough. Hey, did you have any more? Did you want to switch back to the demo, or are you done with your demo?
Yeah, I have one last thing I was going to show off, I guess, before we can break for Q&A. There was, I was going to just dip my toes into showing you one of the many like difficulties in doing the redaction. So like this is one of the major challenges that you come up with when trying to do the unredacting process is the character bleed over problem. So this is just a screen grab from our blog where I kind of like lay out what this looks like. So if you imagine taking this as our original text, right, the image of our text, that we're going to pixelize, that's kind of split into this grid right here, right? And then we're going to pixelate like this based off of this grid, where we're going to average out this text. The problem is that characters are not nicely and neatly separated out into these grids. So it's not T and H share this column of pixels, if you see what I'm saying, that they share this block right here. So if I'm trying to guess things character by character, right, what'll happen is I'll guess the letter T, right, and then not the letter H, because I can't guess the whole thing. The whole point of the program is that I can guess things character by character and not all at once. So I'm going to guess the letter T, right? And so I'll produce these pixels here that you can see on the bottom. The correct guess, the middle one is the guess that I'm making. The correct guess, however, looks like this on the left, because it has this H here that's darkening up quite a bit. So the difference between them winds up producing this middle column is completely wrong. So judging entirely from this, you might reasonably conclude that the letter T is an incorrect guess, because this first column looks pretty good, but the second one looks awful. It doesn't match at all, right? Like this and this column don't match almost at all. And this was a really big challenge. And the way we wound up dealing with this is to kind of prorate our guesses. So what we do is we take this T right here and we chop off the guesses where the T starts. And so we produce an image that looks like this. So instead of having this be our produced difference, where the red is the different, in air quotes, pixels, we wind up with an image that looks like this. So the difference is much smaller. And so we, as a ratio of good to bad, this winds up looking quite a lot better. And in practice, this works pretty well. But this was a pretty persistent problem for a pretty big amount of time. And there's like a ton of these that we running into. This is just the tip of the iceberg in terms of like all the logistical hurdles you have to jump through in order to like make this sort of thing work. So I thought that would be a nice visual thing to kind of show off about like how hard this was to actually program in practice. So yeah, I think that's a good place to stop and break for some Q&A.
Okay, excellent. I'll move over to Q&A, and first I'd like to give a shout out to our audience member who's going to create an issue on GitHub with the details regarding that cross-platform compatibility.
Perfect. So, yeah, that'd be. I honestly don't know why that's happening.
Yeah. So thank you very much for that. I really appreciate it. I actually got another question here as well. I also assume that the font color could also be a factor to consider.
Yeah, absolutely. Basically anything that shows up visually is important to grab. And so the color usually is pretty obvious, but sometimes isn't. They might use like a tricky color that's like an off black like font. And so that might be something you want to pay close attention to. I would say that most people don't, but that will show through in the pixelation. So like in all these images you're seeing here, it's just in black and white. But that might not necessarily always be the case. This is just the simple average of the pixels that appear in the document. So if they happen to be red or blue or whatever, you'll see red and blue pixels show up in the pixelated text, in the redacted text.
Yeah, we've got another question here, which I know that you had encountered this as well. Very observant question. Should an early step always be to crop and then flatten into grayscale?
Yeah, so the flattening into grayscale, I guess, was that a question for like in doing the unredacting process, or was that for if I should redact my text, what should I do?
I think it's prior to executing Unredactor is the way that I read it from the question as I see it.
Yeah, so grayscaling it helps out a lot for, I guess this problem comes up. I know that we have a good example of it. I'll share my screen again. So at the time I wrote this blog post, I actually didn't know what caused this. It's called subpixel rendering. So some renderers will do this, where if you zoom way in on some text, like this was Notepad. So if you go into Windows, at least on Windows 10, it is very variable depending on minute details of like what versions of software renderers using or whatever. But this is how it looks. It does this subpixel rendering thing where this was black and white text when I made it. But if you just like screenshot it and then zoom way in, it looks like this. So it has this like kind of text thing. And it looks fine from like a distance, but if you look way in, it does this. And so this subpixel rendering, when you wind up actually redacting it, it looks like this. And you can see there's a little color in there. There's blue pixels, there's kind of orange pixels, and it's because of this subpixel rendering. And so one way of kind of dealing with this is to not try to get the subpixel rendering right, because you're just never going to. It's going to be so random and different every single time. The easiest way is to just grayscale it. So that's what I did when we solved that jump sec challenge. So I just grayscaled this image. And then the version of headless Chrome that I'm using doesn't do subpixel rendering. But depending on what version of Electron and Chrome you're using, sometimes it will do the subpixel rendering. And I don't have maybe there's a way of turning it off, but I couldn't find it. So that is maybe a good explanation for that.
No, that's perfect. Okay, we've got a couple more questions here to cover. I know we're a little bit over the 30-minute mark. I'll try to get these questions in here. Again, if I don't address any of your questions here, feel free to send it to us afterwards, and we'll be sure to get those answered as promptly as possible. So here's the first question. Are there any good examples of poorly redacted text in the wild?
Yeah, so this is a funny story. So I tried to not like throw anyone under the bus publicly, you know, like in this, like this is pixelating text is like a thing you see in the wild a bunch. If you try looking for it, you'll find it. But I had one anecdote that I thought was good and probably safe to share. So I'm also a bit of a documentary buff. I love watching documentaries. And I was watching this one a while ago that was on PBS Frontline. Makes great documentaries. And I think they were talking about the Panama Papers, which is why I think this was safe to describe. And so on screen, they showed like a document from the Panama Papers that was redacted using pixelated text. And I remember showing Joe this at the time. I was like, hey, check this out. Like, there's a good example. Maybe I could use this. I wound up not using it live, like in the things, because I still just didn't want to call them out. And I think it's safe because, like, to talk about, because there was the Panama Papers. It's all public. If you really wanted to find those documents, you could find them in plain text without the redactions. It's all out there on the internet. And so I was watching one just recently that was after I'd put Unredactor out into the wild. And a similar thing happened. Talking about something, they showed some sensitive document, they had some redacted information in the document, and lo and behold, it was blurred, not pixelated. And so I thought, I'm not saying it was necessarily because of the research that I did, but it was suspicious how they changed the redaction technique. They get partial credit for not using pixelated text anymore, but only partial credit because they didn't use black bars fully occluding the sensitive information, which is what they should have done. Blurring, however, not an especially sensitive information. A good way to redacting sensitive information definitely still leaks data.
Yeah, which obviously it's a great segue into this final question for the day here. Why target pixelation and not some other redaction technique like blurring or swirling?
Yeah, I think that of the kind of lossy information, so often swirl is actually not even a lossy process. You can just like unswirl an image depending on the mathematical process of how you do it. So that one, I think it was like pretty easy. Blurring, I felt like you could do, but there's definitely more than one way to blur an image, as you saw in GIMP earlier. And I didn't want to have to deal with that problem of like, well, which blurring algorithm is being used? So like there's that. And then pixelation, I think, honestly, was like the #1 thing that you see. Like there's a ton of videos and images out there. It was the one that I saw the most often myself when we were doing reports and things that people would try to get tricky with. So that was the thing that I had the pet peeve on. It was definitely the one that you could see was like most apparent as like definitely vulnerable, like definitely a thing that you could undo. So that was more or less why I chose that to go after.
Excellent. And looks like one more question here. Final question. Could you use English words as guesses?
Yeah, you totally could. So Unredactor does like a process of guessing things character by character. But like if you knew, for instance, that like these are going to be English words, could you seed that with like specific English words? The answer is totally. That would be a strict improvement to the process. I think in practice it's not necessary, though. That like the character by character guessing works really well. And I would avoid like trying to make any assumptions about what's underneath the characters unless like it's just not working and you think you have an idea about what kind of text might be under there. Maybe if it's not English, if it's like, if you know it's base 64 or something, then there's certain patterns that could be followed, but I don't know, something along those lines, right?
Okay, makes sense. Well, that about does it for today's Tool Talk. Dan, thank you as always for joining us and sharing Unredactor and this backstory and all of the details about it. I think one of the things that I'm kind of chuckling about back in the background here is now that we learned about all of these redaction techniques and we specifically talk about blurring, one of the things that BishopFox has done is created a redaction challenge to test your own redaction reversal skills, specifically for blurring. You can access this link for the challenge and the related content here in this webcast. Our challenge will last through August 14th, and the winners will be announced at DEF CON 30. As always, we'd love your feedback on this Tool Talk. Please remember to fill out our survey and to register for episode 5 of our Tool Talk series, which will be on May 11th, where we explore RipGen and Amass attack surface discovery tools with a few of our really talented Cosmos operators. You can find the registration link for that in the related content section of this presentation console and save your spot at the next Tool Talk episode. So, Dan, thank you once again. Thank you for our audience, and everyone, please have a great day.
My pleasure. Thanks a lot.